Okay, so today we're going over probability, or at least the intro into probability. This is our new unit. There's a few things that we need to go over. We need to go over sets, samples, empty sets, elements, that kind of thing. So we're going to start off with what is a set. A set is a collection of distinct objects. It is noted with little brackets to show anything inside the net is inside the bracket, or the set is inside the bracket. Next thing we're going to talk about are elements. Elements are objects in a set. So in this set, the objects in the set, or the elements, are 1 and 2. 1's an element and 2 is an element. So the elements of my set are 1 and 2. Again, there are items inside my bracket. An empty set is a set with no objects, with no elements. Either noted with 2 empty brackets or the symbol. Either one is correct. A universal set is a set of all objects, under consideration. And it is written with a U. One other thing we need to talk about is a sample. A sample is a portion of a population. So here's an example of a sample. Let's say the sample is numbers the sample is numbers 1 through 10. I would write that S equals, because S is my sample. We're going to make a bracket. Natural numbers. All is natural numbers between 1 and 10. So natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Sometimes it's going to ask you how many numbers are within a set. So the way we look at it is how many outcomes can be used for this. So the number of outcomes of set S is everything inside. So we have 10 numbers inside, so my number of outcomes are 10. And then let's give a set A. Let's say set A. Or even numbers. Oh, no, well, 1, 2, 3, and 4 is set A. So the numbers in the set are what I'm looking for. The total number in the set, 1, 2, there's 4 numbers in my set. So in a set A is 4. Now we're gonna move on to some definitions that you guys need to know. I'm gonna write it a little bit differently. Just to give an example, we're going to look at, I'm gonna write an example, a definition, and a visual to help. And I'm going to give you certain sets based on this information. So we're going to start off with the set definition, the set notation, and a visual. That is a T, by the way, set. You can go all the way down the paper. So I'm going to start off with one definition. It's going to be called a subset. A subset is a set of a set where all elements are in another set. An example is if I put A, subset C, all of the elements A have to be within C. This is the subset notation. The sideways U is the subset notation. If I were to give you something like A is equal to 1, 2, and 4, and C is 1, 2, 3, 4, and 5, I know A is a subset of C because every element in A can be found in C. So we know A is a subset of C because C has a 1 and A has a 1. A has a 2 and C has a 2. And A has a 4 and C has a 4. So it is a subset of C. Here's our visual. Now everything falls under a universal set. We have set C, and set A is completely inside of C. Now we're going to move on to our next definition. It's going to be intersection. Intersection is everything that two sets share. Everything two sets share, and it is noted with an upside down U shape. Let's say A, again, is going to be the same one we had before. We know it's 1, 2, and 4. And B is 2, 4, 6, 8. The intersection, or A intersect B, is everything that they have in common. Well, I see they both have a 2 in common. So, 2 is an intersection. They both have a 4 in common. So 4 is an intersection. So A intersection B has 2 elements, 2 and 4. A good way to look at it is, again, we have our universal set. This is set B, and this is set A. Everything in between is their intersection. Let's move on to the next one. I'm going to try to write a little bit further over. Let's see. Yeah, okay. I'll try to stay within my lines for this one to make it a little easier. So next one is a union. A union is everything between two sets. So we're going to keep the same sets from before, and unions are described with this, a regular U shape. But again, it's not a complete U, it's more like a horseshoe. It's big and long like this. We're going to use the same sets as before. The union of A and B is going to look something like everything in A, which is 1, 2, and 4, and everything else in B that has not already been written. You do not have to rewrite the same number twice. So for the union of A and B, we have 1, 2, 4, 6, and 8. And our visual, we have A, B, our universal set. It's everything in A and B. Doesn't matter what they share, it's just everything in both, one or both sets. The last one we're going to talk about for these definitions, we have one more definition to cover after, is the complement. A complement is everything in the universal set that is not in a given set. So an example for our universal set, let's say my universal set, I'm going to write it down here. is 1, 2, 3, 4, 5, 6, 7, 7. Let's stop at 7. 7, well, I guess 8. Nah, it's fine. 1 through 7 is my universal set. That is everything I'm looking at. The complement of A is going to either be written like this or like this. Let's write what A is. A, again, is 1, 2, and 4. This is my set A. I need to write down that the complement of A is everything in my universal set that is not in A. So I have a 1 in A, so I'm not going to put 1. I have a 2 in A, so I'm not going to put 1. I have a 3 in my universal set, and it is not in A. Well, 4 is in A, so I can't use that one. So my complement of A is 3, 5, 6, and 7. Why? Because it is not in A. So our visualization is going to look something like this. It's everything outside of A. Now let's talk about theoretical probability. Theoretical probability, it is written as P of whatever you're looking for. So in this case, I'm going to use set A, just because. The theoretical probability is the number of outcomes for an event over the number of outcomes for a sample. The best way to look at it is the N of A over the N of S. So we're going to work on a few problems that are looking for theoretical probability, and then you are to do your work for this week, or for today, I mean. So let's start with a given example. Let me get another piece of paper. You roll a 6-sided die. I'm going to write that. You roll a 6-sided die. Event A is rolling a prime number. Event B is rolling an even number. Let's start off by writing our sample. We know a 6-sided die has 1 on one of its sides. It has 2, 3, 4, 5, and 6. 1 for every side. Event A. So let's start with this. We know that N of S is the number of outcomes within our sample. Well, we know there's 6 outcomes because there's 6 numbers in our set, so the number is going to be 6. Event A are prime numbers. Prime numbers for a die are 2, 3, and 5. So the numbers for the set A, or the total number of outcomes for set A, is 3. And event B is an even number, so 2, 4, or 6. So since there are 3 outcomes again, the number of outcomes for set B is also 3. Let's start by finding the probability of A. The likelihood event A will happen. Well, the probability of A is the number of outcomes for event A over the total number of outcomes for the sample, or N of A over N of S. Well, we know the total number of outcomes for set A is 3. And the total number of outcomes for the entire sample is 6. So the probability of rolling a prime number is 3 over 6, or 1/2. Probability of B, same situation. We want the number of outcomes for set B over the total number of outcomes for my set. The number of outcomes for B is 3. The total number of outcomes are 6. So it is the same probability of rolling an even number as it is for rolling a prime number. Let's try the probability of A intersect B. Well, first off, let's write our set of A intersect B. We know A and the intersection of A and B are the numbers that they both share. So looking at my two sets, they only share a 2. So this, the number of outcomes for the intersection of A and B is just 1. So the probability of A and B is the number of outcomes for A union B over the number for the entire sample, or 1 over 6. And our last one for this problem, A union B. The probability of A union B. Well, let's start by making our set for A union B, and that's everything in A and B. Well, there's a 2 in A and a 2 in B. There's a 3 in A. There's a 4 in B. There's a 5 in A and a 6 in B. The total number of outcomes for A union B are 1, 2, 3, 4, 5 numbers. So there are 5 outcomes. So the probability of A union B is equal to the number of outcomes for A union B over the total number of outcomes for our sample, or 5 over 6. That is our probability. Now, one thing I must note, probability is either a fraction or a decimal, 1 or less. It can never be greater than 1. Your probability can never be greater than 1. And let's do one more example. I'm not going to write out the full statement, but let's just say we have a grocery basket. And in this grocery basket, we have green apples, green grapes, broccoli, orange carrots, cauliflower, spinach, and oranges. This is everything in my my grocery basket. Event A is grabbing a vegetable. That's fine. Grabbing a vegetable. So for event A, let's list off every vegetable in my group. Well, we have broccoli, carrots, cauliflower, and spinach. For event A, we have 4 items, or 4 outcomes. For our total sample, we have 1, 2, 3, 4, 5, 6, 7 total outcomes. Event B is grabbing a green food. So we're going to list off all the green foods to begin with. We have broccoli, spinach, grapes, and apples. So the number of total outcomes for event B is 1, 2, 3, 4. So let's find the probability of B. So the probability of B, again, is the number of outcomes for B over the number of outcomes for our sample. Well, B is 4, and our sample is 7, so 4 over 7. Let's do probability of A union B. Well, let's write out all of our sample, or all of our sets for A union B. So looking at A union B is everything that they share and everything that they don't share. So basically everything in each of these. So first off, I know they both have broccoli. One has carrots. They both have spinach. One has grapes. One has cauliflower. One has apples. So for this one, we have a lot of items in their union. We know we have for A union B, we have 1, 2, 3, 4, 5, 6 outcomes. So for the probability of A union B, we're going to write the number of outcomes for A union B over the number of outcomes for our sample, or 6 over 7. And let's do one more example. Find the probability of the complement of A. Well, let's start off by listing our complement of A. The complement of A is everything in our universal or our sample set that is not found in A. Well, A are vegetables, so the ones that aren't in set A are all the fruit, or apples, oranges, and grapes. For this one, the complement of A has 3 outcomes. So the probability for the complement of A is the number of outcomes for the complement over the number of total outcomes, or 3 over 7. All right, you guys have page 911 in your textbook to work on. If you don't have a textbook, make sure you message me on Schoology and I'll let you know. You're going to do numbers 1 through 17.